Hello friends, today we are going to look at a numerical method called bisection method. Bisection method can be used to solve a nonlinear equation, and this bisection method belongs to a group called closed domain or bracketing methods. The nonlinear equation, for example, f of x equals 0, could be an algebraic equation consisting of x, x squared, etc. Or it could be a transcendental equation consisting of x, trigonometric functions, exponential functions, logarithmic functions, etc. Some examples of nonlinear equations are given below. The first one is an algebraic equation. The second one is a transcendental equation. So the bisection method, the procedure to solve is given below. So f of x is the curve shown here, and we should know 2 points A and B, and we should know that the exact root alpha lies between A and B. The first step is we need to calculate the midpoint C. C equals A plus B by 2. So once we find out C, we need to find out the function f of x at C, that is f of C, and the function f of x at A, f of A. So we multiply f of A times f of C. So if the value is negative, then we know that the root lies between A and C, as shown in the left hand side. If the value is positive, then we think the root should be present between C and B. So again, once we establish, for example, on the left hand side A and C, the new x values, so we need to bisect this once again, and we come out with a new C value consisting of A plus old C divided by 2, and we continue this procedure. So the bisection method algorithm is given below. As mentioned before, C equals A plus B by 2, and if f of A times f of C is lesser than 0, then the root should lie between A and C, so A remains as A and B becomes C. If f of A times f of C is greater than 0, the root should be present in the other half, so A becomes C and B remains the same. So an iteration stopping criteria needs to be used. So if Bi minus Ai is lesser than the tolerance value epsilon 1, we can stop the iteration. So where Bi and Ai are the x values. The other option is we need to find out the function f of x at location C. So f of C, if it is lesser than or equal to a set value, tolerance value epsilon 2, then the iteration can be stopped. Now we can go back and look at the MATLAB program. So the bisection method is given here. So initially we should know that the root should lie between the x values A and B. So the root should lie in this case between 0 and 2. So if we pick the wrong, if the root, for example, does not lie between A and B, this method does not work. So we kept the iterations to a maximum of 100, and the algorithm is given here as we discussed. And the criteria, stopping criteria, is set at 1 equals minus 6 f of C. The function f of x are the root location, the estimated root location f of C. If it is lesser than 1 equals minus 6, then you can stop the iteration. So we run this, and The program used 22 iterations and the root is located at x equals 1.678347, and at that location f of x equals is very close to 0. So the equation in this case we used is the transcendental equation, the second equation. We can even look at it graphically. So the root here, that's the transcendental equation we used, and the root is 1.6768, and the root we calculated using this bisection method is this is more accurate than what we saw graphically. We can try the second equation, or rather the first equation, the algebraic equation, and run the program a second time. So the algebraic equation in this case we consider as f of x equals x cubed minus 2x squared minus 2x plus 1, which is a nonlinear equation. We run this once again, and again it took about 22 iterations to meet our stopping criteria. So the root is calculated to be 0.381966, and the function at f of x at this root is very close to 0. We can look at it graphically, and the value over here is 38384, which is not accurate when compared with the analytical the results we obtained using bisection method. So we can go back to the PowerPoint. To summarize, we presented bisection method to solve nonlinear equations. The nonlinear equations can be in the form of algebraic equations, or it can be in the form of transcendental equations, as discussed before. Bisection method belongs to a group called closed domain or bracketing methods. In the next video, we can look at another bracketing method called regular falsi method, which is an improvement over the bisection method. If you have any questions, please post it. Thanks for watching the video.